This is 7-1 in advanced geometry. It's about ratios and proportions. What a ratio is, it's a comparison of two quantities using division. So here on number 1, if a tight end scored 6 touchdowns in 14 games, find the ratio of touchdowns per game. They tell you what order to put these in, and the secret to these problems is just the label. It's all about the label. So if they want touchdowns per game, they scored 6 touchdowns, and I can abbreviate touchdowns, of course, in 14 games. And then all we really have to do is reduce that fraction. 6 over 14 reduces to 3/7. So, sorry, say 7, and the label's got to come with them. So this tight end scored 3 touchdowns for every 7 games. This is a ratio. You might confuse it with a rate every once in a while, where rates always have to be over 1. We do not care about a rate in this situation. We just care about a ratio. Just reduce the fraction that ended up happening. So in a schedule of 6 classes, Marta had 2 elective classes. What is the ratio of elective to non-elective? A lot of times it's a good idea to get your labels going first. So if they say, what's the ratio of elective to non-elective, you can set up your fraction like this. She took 2 elective classes, so 2, and 6, you got to be careful and read for detail. 6 is the total number of classes she took. So if there's 6 total and 2 of them were elective, that means 4 was non-elective, meaning that reduces to 1 elective for every 2 non-electives that she took. So why don't you pause the video and give number 3 a shot. Read for detail. And as you can see, they want to do species that are endangered over like the total number of species, or the labels aren't that important of like what they have to be. It's just you have to get the general idea across. So there was definitely 78 endangered, and you don't need to do any subtracting and get a 196. It's 274 is the total number of species, and that will reduce to 39 endangered for every 137 total. An extended ratio is used to compare 3 or more quantities. So the ratio of the measures of the sides of a triangle are 3 to 5 to 7. That's how they relate to each other. One of them is, there's this common multiplier between all of them, which is what we're going to find. One of them is 3 times that, another side is 5 times that, and another one is 7 times that. But make sure you read the magic word here. The ratio of the measures of the sides of a triangle is 3 to 5 to 7. The perimeter is 450 centimeters. Find the measures of each side. Well, here's how we do it. We throw an X next to every number in that ratio and add them together. And that should all add up to be the perimeter of that particular shape. And then we'll combine like terms. 3x and 7x is 10x plus 5 more is 15x. Equals 450. Don't combine like terms right away. Give me that blue equation there so I can see that you used the ratio properly. Now we'll just solve for x, and if you divide both sides by 15, x equals 30. But x is what we call the common multiplier. That's like how all 3 sides relate to each other. There's some sort of factor of 30 in there. To find the 3 side lengths, you take this common multiplier times every number in your ratio. So 3 times 30 is 90 centimeters is one of the side lengths. 5 times 30 is 150 centimeters, and then the last one is 210 centimeters. And they should all add up to be 450 in this case. That was about sides. The ratio of the measures of the sides of a triangle is 5 to 6 to 9, and the perimeter is 220. Find the side lengths. So, same concept. Throw an X next to every one of those dudes in your ratio, and they should all add up to be 220. And then add these together and still get 15. Sorry, that's 20x, my bad. I don't know what I was thinking. 20x equals 220. And if you divide by 20, x equals 11. And then to find the side length, you take 11 times every number in the ratio. So you'd get 55. Label is meters. And then 66 meters. And 99 meters. And then here, don't assume that they're all the same. Find the ratio of the measures of the 3 angles. of a triangle, so they had sides. Now they give me angles. So the three angles of a triangle is 3 to 4 to 5. We have to use previous knowledge that we know that all three angles add up to be 180 degrees. So we'll throw an X next to every number in the ratio, and they should all add up to equal 180 since this is the angles of the triangle. So we'll add them up and get 12 x's equals 180, and then divide both sides by 12, and x equals 15. And then to find the three angles, we just take 15 times each number in the ratio again. 3 times 15 is 45, and it's angle measure, so we label that in degrees. 4 times 15 is 60 degrees, and 4 times 5 is 75 degrees. So there we go. What a proportion is two ratios that are equal to each other. So you got a ratio of 2/5 here. You got a ratio of x over 40 here. They're equal to each other. Excuse me. To solve a proportion, you do a little thing called cross multiply. You want to take these two rows times each other and get an 80, and then bring your equal sign down, and then take these two rows times each other and get a 5x. Now it doesn't really matter what order you do them in, because you just got to take the red things times each other and the green things times each other. If you had 5x equals 80, that's the same thing, you know, with the symmetric property. So then divide both sides by 5 and get x equals 16. There's many ways to figure these out, guys. All I'm asking you to do is do a little cross multiply. Don't do it all in your head, one step at a time. I mean, sure, you can use your brain. You don't have to use a calculator, but write down each little step. So cross multiply here, 7x equals 210, to where x equals 30 if we divide both sides by 7. Same thing, 20 times 6 is 120. That equals 5 times 4x, which is 20x. And then we'll divide both sides by 20 and get 6. Why don't you get number 10 a try? Give the video a pause and get number 10 a try. When you cross multiplied, you should get 40x equals 140, and then we'll divide both sides by 40, and that doesn't come out nice. You know, I mean, it's not the ugliest thing in the world, but let's pretend I didn't reduce it for a second. This is what you get. We can definitely reduce that puppy because the zeros will cancel because 10 goes in each one, and 14 over 4 is really 7 over 2. I know 3.5 is a nice clean number, but when it comes to an algebra problem, right, this is algebra, there's no story involved with it. I want an improper fraction. I don't want 3 1/2, which is a compound fraction. I don't want 3.5, which is a decimal. I want an improper fraction on algebra problems. Here on number 11, here's a fraction bar. A fraction bar is really a group, so if you have more than one term in either the numerator or denominator, you should put parentheses around it. And when we cross multiply, we'll take 2 times that whole group of parentheses right there and set that equal to 7 times 3, which is, of course, 21. And then the next move here is to distribute. I know a lot of people try to just distribute right away. I advise you to not do that. More mistakes happen that way than you would imagine. So put parentheses around it and bring her on down, then distribute. And then subtract 2 from both sides and get 2x equals 19. And divide by 2, and that doesn't come out nice, so we'll leave it 19 halves. Number 12, again, more than one term in a numerator or denominator, so we'll group it, and then we will cross multiply. 5 times 15 is 75, and that will equal 3 times that whole group right there. And then we'll distribute. Add 9 to both sides, and get an 84. And then divide both sides by 3, and x equals 28. So, algebra problems. When it comes to the story problems, we will set up a proportion with labels to solve. It's much easier than you think if you put the labels. So, Myra is playing a board game. After 12 turns, Myra has landed on a blue space 3 times. If the game will last for 100 turns, predict how many times Myra will land on a blue space. So, from all this information given to us, they should have given us some sort of ratio that we could write. And they did it right here. 12 turns, she landed on blue 3 times. So, we could write this, 12 turns, there was 3 blue. That's one possible ratio you could have written. Notice the labels that I put with it. The other ratio you could have written was just flip the whole thing upside down and say 3 blue for every 12 turns. You know, it doesn't really matter. They didn't tell you, like in the first problems with the touchdowns per game, they didn't tell you which one had to be on top and which one had to be on bottom. So, your choice. But when you set up your proportion, which is two fractions equal to each other, throw an equal sign, throw another fraction bar, and if this guy is turns over blue, this guy must be turns over blue. And when I grade these, I grade the labels the hardest. There's one problem here, 4 different labels, turns blue, turns blue. What they also provided us was this number 100. The word turns is next to it, so 100 goes next to turns. And what we don't know is how many times blue showed up, so we will call that X in mathematics. So that's how to set up the proportion. Now to solve it, you just cross multiply, and we could care less about the labels at this point, but we needed the labels to make sure we had the 12, the 3, and the 100 all in the right place. So we'll cross multiply. 12 times x is 12x, and 3 times 100 is 300. And then we will divide both sides by 12 and realize that x equals 25. And now we'll answer the question. X had a label of blue next to it, so our label needs to have something to do with blue. We're kind of going to turn it into a little phrase here. So 25 times she should land on blue. And that's just a prediction, right? Based on what happened here, you know, predict what would happen if she rolled 100 times. Well, we predict that she should land on blue 25 times. The ratio of male students to female students in the drama club is 3 to 4. So we definitely know the ratio is 3 to 4. And they used a colon. We're going to change them to fractions all the time. And since they said male to female, that means since 3 came first, 3 males for every 4 females. Like I said, you can abbreviate your labels M and F for male and female. So then we'll set it up with another fraction. If that's male over female, this has to be male over female. And they say the number of males is 18, so 18 goes there. Predict the number of females. Why don't you solve that by cross multiplying? 4 times 18 is 40, and 32, which would be 72. And divide by shui, and get 24 females. How do I know females? Because that's what the label is next to X in my proportion. A farmer is supposed to mix a herbicide in the ratio of 5 pounds of herbicide for every 12 gallons of water. So we'll write a ratio with that information. 5 pounds for every 12 gallons. The labels aren't the most specific thing. It could have been like 5 herbicide for every 12 water or whatever. You know, it's just you got to have something to distinguish the difference between those two concepts right here. If this is pounds over gallons, this guy's got to be pounds over gallons. They say he's got a 240 gallon tank, so that goes down here, and we call that X. Once you pause the video, solve, and make sure you label your answer. And hopefully, when you cross multiplied, you got 1200 equals 12x, so x equals 100, meaning that's 100 pounds of herbicide. Don't just say 100 pounds. 100 pounds of herbicide, like answer the question. A recipe calls for a 1/4 cup of vanilla for every 3 eggs. So I'm going to show you how to cheat a little bit. Because this is a story problem, decimals are going to be okay. I'll explain when I'm done. But a recipe calls for a 1/4 cup vanilla, 0.25 vanilla, I'll just change that to a decimal, for every 3 eggs. And if this guy's vanilla over eggs, then this guy is going to be vanilla over eggs. For a large party, Mary used 2.5 cups of vanilla, so 2.5 vanilla, and then x eggs. So solve by cross multiplication. 0.25x will equal 3 times 2.5, which is 7.5. Then divide both sides by 0.25 and get 30 eggs. Now, I do know that this one came out nice, but back to my story situation, like when you go to a real life place, like let's say a hardware store, and you need to get some lumber, you don't go back there and be like, excuse me, can I get 9/2 feet of lumber, 9/2, which is an improper fraction, just doesn't make any sense. 4 1/2 feet makes sense, even though it's the same number. When it comes to a story problem, a compound fraction or a decimal makes sense. But when you get back here, these are not story problems. They are algebra problems. So I don't want a compound fraction. I want improper fractions. So story problems, I don't care what you give me for an answer, something that makes sense. But an algebra problem, got to be improper fractions. So last one. Sam and Bill agreed to split the profits of their company in a 2-to-3 ratio because Bill invested more money than Sam. So we definitely know the ratio is 2-to-3. And what you can't do is this. You can't say $2 for every $3. You don't want the labels to be the same. That's bad news there. You got to have something to distinguish between the two. And what would be the best idea is probably their names, Sam and Bill. The question is, who goes by what number? So, a 2-to-3 ratio, Bill invested more money than Sam. So since Bill had more money, Bill would go by the bigger number. 3 is the bigger number. And Sam goes up here. So for every $2 that Sam invested, Bill invested $3. And if this guy is Sam over Bill, and this guy is Sam over Bill. And they said Sam made $4,500 in profits. How much profit did Bill make? So we don't know that. Cross multiply. 2x equals 4,500 times 3. Large numbers need commas. Then divide by 2. 6750. And that would be dollars profit for Bill. So I went through that pretty fast. I think that you'll get the concept. But the homework is all from the book. It's section 7-1. You'll do problems 1 through 30, 50 through 53, and 57. So you can pause the video here to write that down. Let me know if you have any questions, and have a good one.